For today, the first thing we need to talk about is STP, which stands for standard temperature and pressure. So a lot of reactions are dependent on the temperature and the pressure of where you're doing the reaction. So sometimes scientists like to set those constant so you don't have to worry about how the temperature or pressure affects the reaction. So standard temperature is 0 degrees Celsius, which is the freezing point of water, and standard pressure is 1 atm. You don't need to memorize those, they're in your reference tables. And actually, we're not going to use those very much at all for this chapter. You just need to know what STP stands for. Once we get to thermodynamics, we'll use those numbers a lot. So now we can talk about Avogadro's hypothesis. What he said is that equal volumes of gases at the same temperature and pressure have equal particles. So basically, if you set the volume, the temperature, and the pressure constant, you have to have the same number of particles in whatever container you have. And the reason that's important is because it gives us a new conversion factor. So if we say at STP, so we're going to set temperature and temperature and pressure standard. If we have 1 mole, we can say that we always know how much volume it occupies. It's always going to be 22.4 liters. So now we can use this new conversion factor, where 1 mole is equal to 22.4 liters. But I want you to circle gases, and I want you to circle STP. This conversion factor, 1 mole equals 22.4 liters, that only works for gases. So if you have liquids, it doesn't work, and it only works if you're at standard temperature and standard pressure. So if you were at 20 degrees Celsius, then this conversion factor wouldn't work. For this class, I'll always give you those conditions. It'll always be a gas at STP, so you don't really need to worry about it. But when I taught AP Chemistry, a lot of my AP students would try to use this conversion factor when they didn't have these conditions, and it doesn't work. So just keep in mind that in the future, if you take an upper-level chemistry class, like college chemistry or AP Chemistry, this conversion factor will only work under these conditions. If the question doesn't say it's a gas, then you can't use it. And if it doesn't say it's at STP, you can't use it as well. But like I said, for this class, you'll always be able to use it. So now we're just going to do the conversions like we've been doing. So if we have 4 moles of helium and I want to know how many liters it is, start with what you're given in the top left corner. So 5.4 moles of helium goes up here. You want to cancel the unit of moles, so bring that down diagonal. And you're trying to turn it into liters, so that goes on top. And the conversion factor is that 1 mole is equal to 22.4 liters. So 1 needs to go with wherever you wrote mole, and 22.4 goes with the unit of liters. And then you just do the math. So 5.4 times 22.4 should be about 121. And this number, the 22.4, that's in your reference tables as well, so you don't need to memorize that. Let's try another one. If we have 5.4 moles of methane, which is CH4, let's see if we can figure out the liters. So start with what you're given in the top left corner, 5.4 moles. Bring your moles down. You're turning it into liters, and plug in your numbers. So 22.4 liters is equal to 1 mole. And hopefully you just made an observation. Notice that this answer is the exact same answer as the previous question. The point I'm trying to make here is that it doesn't matter what chemical you have. If you have carbon dioxide or oxygen or whatever, if you're converting it into liters, since this number is always constant for anything, for any of the gases, it's not going to make a difference what chemical you have. That's what I was trying to show you here. And one more if we go backwards. If we have 560 liters, this time you're going to start with liters on the top left. So you bring it down, plug in your moles, and then put your numbers. So 22.4 goes with the liters, 1 goes with the mole. Notice that this time the 22.4 is on the bottom of the fraction, and on the previous one it was on the top. So again, you can't memorize where to put these numbers. You have to just set up your units because every question is going to be different. So 560 times 1 divided by 22.4 should give you about 25 moles. For this next part, there's 2 units that you're going to need to memorize. So density we've talked about several times. You guys know that density is mass over volume. So for mass, we measured in grams, and volume is either liters or milliliters. In this case, we're going to use liters. So put a star by this fraction and make sure you memorize that density is always grams divided by liters. It's mass over volume. Molar mass is what we have on the periodic table, and we talked about that yesterday, that it's not just grams, it's grams per mole. So it's a ratio that's on the periodic table, it's not an amount. Notice that these two fractions are exactly the same, except this one has mole on the bottom and this one has liters on the bottom. Put a star by this fraction too, and make sure you memorize this one as well. If you know these two units by heart, it's going to make life a whole lot easier for you. So let's look at this question. It says we have 3.58 grams per liter. This is the density. And remember, when you have a fraction as a unit, you need to split it up on your fence. So you're going to make it 3.58 grams divided by liters. So make sure you split that up. Notice that for these two, we have grams on the top, so we're going to leave those alone. We don't want to change the grams. But on the bottom, instead of liters, what we want now is moles, because we're looking for the molar mass. So I needed to cancel liters by bringing it up here diagonal and putting moles on the bottom. And then I just plug in the numbers. 1 mole is equal to 22.4 liters. So then when you cancel this, liters cancels liters, and you have grams on the top, moles on the bottom, and that's exactly what molar mass is. So again, if you memorize this fraction, you know that unit, it's going to make it easy for you. So 3.58 times 22.4 should give you close to 80 grams per mole. And notice that I have a fraction as a unit, because all of these units are fractions. In this question, of all the questions on my test and quiz for this chapter, this is the one that's missed most commonly. So I'm going to give you one very similar to this on the test and quiz, and a lot of people are going to miss it because if you look at this question, it looks like you're missing a number. There's no number to start with, so it's like, well, how do you set up your fence if you have no calculations to start with? But you do have a number because I told you the element. So since I told you it was krypton, what you can do is look at the periodic table for krypton and find the mass, and you should know that that is molar mass, which is grams per mole. So if you look at the periodic table, it's 83 grams per mole for krypton. That's the molar mass. Don't forget to separate grams and moles on your fence. What you're looking for is density. So if we go back to the previous slide, let's see. So if we go back to this slide, notice that density is grams over liters. So what we want to end up with is grams over liters, and what we're starting with is grams per mole. So we started with grams per mole. What we want to end up with is liters, so I took that mole and brought it up diagonal, and then plugged in my numbers. So 1 mole is equal to 22.4 liters. Now moles cancel, and notice that we have grams on top and liters on the bottom, and that's a unit for density. So 83.8 divided by 22.4. And again, notice that the unit here is grams per liter. If you're ever doing density or molar mass, you're going to have a fraction for your unit. And the last thing for today is putting it all together. So go ahead and take a minute. You can pause the video if you need to. Take a minute and fill in this picture because it's going to help you see how we're going to convert from one to another. So pause this video for a minute and go ahead and fill that in. And once you've gotten it filled in, what I want you to see is this is the connection for how you can calculate different things. So if we wanted to know grams, and I gave you molecules, which is a type of particle, notice there's no direct connection between grams and particles, so you can't do it in one step. But what you can do is turn particles into mole using Avogadro's number. Then you can go from moles to grams. Or if you wanted to go grams to moles to liters, or if you wanted to go liters to moles to particles, so you can move anywhere on this picture now. You have enough chemistry knowledge. So let's look at this question. It says, if you had 5 liters of CO2, how many grams would that be? So if you look back at that picture, there's not a direct connection between liters and grams, but there's a link between them, and that's moles. So the first step is we need to turn it into moles, then we can turn the moles into grams. So start with what you're given on the top left corner, so 5 liters of CO2. The first step is we need to turn it into moles. So the only thing you can turn liters into is moles. So bring that liter down, turn it into moles on top, and plug in your numbers. 1 mole is equal to 22.4 liters. Now liters cancels, and we have moles, which will allow us to go to grams. So now we're going to cancel moles, bring that down diagonal, and put grams on top. And remember, I told you yesterday, for this chapter, whenever you see grams, you need to think periodic table. So this number 44 came from the periodic table. We added up 1 carbon, which is 12 grams per mole, and then 2 oxygens. Each oxygen is 16. So 16 times 2 is 32, plus another 12 from the carbon, that's where I got the 44. Check your units, so notice liters cancels liters, moles cancels moles, and what we're left with is grams. So it's just 5 times 44 divided by 22.4. Alright, last one for today. Go ahead and pause this video for a minute if you haven't done it and see if you can set this one up. You're saying if we have 60 grams of water, I want to know exactly how many molecules of water would be in that beaker. So pause the video, set it up yourself, and then check your answer. And see how you did. So we started with grams. Pull the grams down diagonal to cancel it. The only thing you can turn grams into is moles. So notice that was our first step. This number 18 came from the periodic table. So oxygen is 16, each hydrogen is 1, for a total of 18 grams per 1 mole. But we didn't want moles, we want molecules. So you need to take the mole, pull it down diagonal, and put molecules on top. And the relationship between moles and particles is Avogadro's number, but make sure you put his number with molecules and 1 with the mole. Check that your units cancel, so grams cancels grams, moles cancels moles, and we're left with molecules. So you should get about 2 times 10 to the 24th molecules. And that's all for today. What I want you to work on is worksheets 5 and 6 in your packet. They'll let you practice these kinds of problems in worksheets 5 and 6, and all the answers should be on there, so make sure you check your answers as you work to see if you got them right. And that's it.